This video is going to walk you through how to set up a dihybrid cross. So you just got done watching the Amoeba Sisters video and you saw that dihybrid means that there's two genes or traits, you could think of two. So the parents and the children are going to have four different alleles, four letters. And so just like when we have a monohybrid cross, right? And let's say we have some parents. The parents have two alleles. Oops. So do the kids. So for a double, it's going to be 4. Then it's going to go to kids 4. But the gametes are half. So remember, the top of Punnett squares are haploid. So usually there's just one for a single trait. However, now that we're doing two genes, the gametes are going to have 2. And they should be different letters, one for each gene. So this example with guinea pigs is looking at hair of guinea pigs in terms of color, black hair, meat being dominant, white hair being recessive. And in addition to color, it's looking at length. Short hair being dominant, big L, long hair being recessive. So we have this weird looking guinea pig here that's all recessive, homozygous recessive for both. So this example is saying we've got some parents, and the parents are both homozygous for both traits, homozygous dominant, homozygous recessive. Now, when they have their gametes, this one is easy because this parent only has a big B and only a big L. This parent only has a little b and only a little l, so that's the only options for the gametes to separate, or for the alleles to separate in the gametes. But remember, when it's a little bit harder, like the next process, you need to use the FOIL method. If you skipped the Amoeba Sister video, go watch it. The FOIL method is just like math. First, outside, inside, last. So we're going to use that now for these parents. So this example is saying, here are these parents, they have babies. Now let's say those babies breed. Notice that the two homozygous parents had 2 all heterozygous babies. And so to figure out what would be up here and what would be down here, it's already done for you on this one, but I want to show you how it would be done. So I'm going to take that parent genotype and we're going to just follow FOIL. So first B, first L. Outside B, outside L. Inside B, inside L. Last B, last L. These now are the 4 options that go in the gametes. It doesn't matter which order you do. They kind of did FOIL, just like I did here, but that doesn't matter. Now, when you are performing the cross, we always put letters of the same together. It would be really tempting to go like this. B, L, B, L. That's really confusing though when we're trying to figure out the phenotypes because the B's aren't together and the L's aren't together. Don't do it that way. Do it instead by doing the B's first, L's second. Remember, always keep capital letters first and then lowercase second. So follow along with me. It's really easy to make mistakes, but I will show you how to oftentimes catch your mistakes. Hopefully I haven't already made one as I talk about how easy it is. All right, so when we're thinking about the phenotype ratios, there are only certain phenotype ratios that always happen. Let's count them out and see what ours are. So now I'm looking for black hair and short. When I'm doing this, I often think, what is the genotype going to be for this? So black is dominant, so I'm looking for a big B, at least one. Short is also dominant, so I'm looking for a big L, at least one. It's easy because there's pictures here. There won't often be pictures, / never. So I'm looking for a big B and a big L, and I'm going to count it. I also will cross them out as I'm going. So a big B here and a big L. 1, 2, 3, 4, 5. Nope. 6. Nope. 7, 8, 9. Black and long. Now I can see what I've crossed out, which is great. So dominant, big B. Long is recessive, little L's. 1, 2. I already know I didn't count. Yep, 3. White and short. So white, recessive, short, dominant. 1, 2, 3. White and long, 1. Now, how to check your work here is by adding up these numbers. There's 16 squares in a dihybrid double Punnett square, so this better add up to 16, which it does. Now, other ratios that you can get are 4, 4, 4, 4. Sometimes you can get 8, 8. You can get 16 and 0. But you cannot in the 9, 3, 3, 1. There are no other combinations. If you get 10, if you get 2, something is wrong. You can never get those numbers regardless of the gametes, regardless of the traits. It's really important to double check this part. And if it's not one of these sort of ratio counting options, you know something happened. So that is the end of this example here. On the next example, you are doing it on your own. I will show you how to go through foil and set it up, and then I'm going to let you do the rest of the Punnett square. So in order to figure out the gametes, we have to use the foil method. So I'm going to take this parent here, I'm going to rewrite it over here, and I'm going to go through foil. F stands for first. First B, first L. O stands for outside. Outside B, outside L. I stands for inside. Inside B, inside L. L stands for last. Last B, last L. Now you can always double check. Looking here, we have homozygous for little L's, so all should have little L's. And then half of the B's are big and half are small, so half should be big and half should be small. When I have the same thing here, I write them next to each other. Oops, wrong one. This is this parent. I do that because it's easier to fill in the Punnett square. So just a little bit of advice. Now doing this parent, we could look at it and see there's only little b's. There's only big L's. Therefore, there's only those options. Now this Punnett square will be a little bit easier because these are all the same, which makes our life very, very happy. So I'm going to show you a technique. It's a bit lazy, but I think it's easier. So let's just do this first row here. So big B, little b, big L, little l. Now because these are the same as this one, that is the same too. It's okay to put an arrow through. And you know what? Since this is the same as this one, arrows are totally fine. You can include them there on Google Draw, and it saves you time and also is way easier when you're figuring out phenotypic ratios. Good luck as you work through more individual practice. If I went way too fast and you're still confused, go rewatch the Amoeba Sisters video.